right, folks, so this elephant holding this log in his trunk is going to help us figure out how logs are a way of rewriting exponential form. Now, exponential form, we're pretty familiar with the parts. We've got the base, we've got the exponent, and then we're going to call what it's equal to the answer. So, looking at this problem, we're going to say that 3 squared is 9. We're on page 3, up at the top, skipping page 2 for right now. We're going to say that 3 is the base, 2 is the exponent, and we're going to call 9 the answer. So in a general sense, we could say that exponential form is base raised to an exponent equals an answer. So that is exponential form. Now to the right, what we are going to see is that logs are another way of rewriting exponential form. So we call this logarithmic form. It's spelled logarithmic form. And it is a way of rewriting. Now, one thing we have seen before with going back and forth between two forms was the last unit. So if I have the square root of x in radical form, in the last unit we said we could also write that as x to the 1/2 power, right? Right. So this is radical form. This is exponential form. Now, we're going to go from exponential form to logarithmic form. The buy-in, I imagine, is going to be particularly low. It's like, why would we use this new terrible thing when exponential form seems to do the job just fine? I forget which class I mentioned it to on Friday, but the whole purpose of logs is going to be to solve currently unsolvable equations. So let's say I have to the x equals 8. What is the only thing that x can be equal to make this true? 3. Thank you for not saying 4. So x is 3. And we figured this out just from, kind of guessing and checking. But what if I told you to solve it algebraically? As in, what if I told you to isolate x? Some of you might say, let's divide by 2. But if I divide by 2, what do we get? 4, which is not the right answer. And then I would just have that floating exponent up in the air, which doesn't make any sense either. Currently, we don't have any way of solving this other than by guessing and checking. And if I encounter something like this, then we would really be stuck as far as how to solve that algebraically. So right now, we are just going to be using logs as a way of rewriting exponential form. But later, once we get into solving, we will see how logs are a way of simplifying and solving. So it's kind of like how if you went from this to this, it's like, all right, these two forms are a way of rewriting each other, but then I can also use square rooting as an operation of both sides and say that x equals plus or minus 2. So in a similar sense, logs are going to be a way of rewriting exponential form, but they are also going to be an algebraic operator that we can use for solving. So right now, day 1, we are just going to focus on the rewriting part. So if I wanted to rewrite this exact same expression in logarithmic form, it would look like log subscript 3. So subscript means lower, kind of like the lower level of an exponent. Drop it down. And then ground level 9 equals 2. So these two forms mean the exact same thing. And the parts go in the order of base, answer, exponent. And my dumb way of remembering this is we see the word log and we think of the elephant holding it in his trunk with his big animal ears. So the elephant has big animal ears. Now, most students will be up and they go, no, I'll remember Bay. It's all good. I'll remember that. Big animal ears is helpful because it only works when you have the log out in front. So that elephant has to be holding the log first before you can say big animal ears. So that is the order that my exponential stuff goes in when we write it in logarithmic form. So log, base, answer, exponent. Big animal ears. We're also going to practice reading it because how I said it, log and then a subscript 3 and then a ground level 9 equals 2, that's not how we actually read it. So this is kind of a new language for us, so we're just going to practice reading this expression. This says log base 3 of 9 equals 2. Log base 3 of 9 equals 2. Say it with me. Log base 3 of 9 equals 2. Let's try another one. Log base 2 of 32 equals 5. Ooh, what's this one? That's called a natural log. More on that later. So log base 5 of 5 will be equal to something. So big animal ears is going to be our strategy for organizing the parts of exponential form in its corresponding logarithmic form. So there's lots of stuff in this top box, but what I want you to take to heart is natural log, which is ln, is log base e. Natural log is a short, fancy way of writing log base e, and if you're like, what's E? E is an irrational constant, kind of like pi. They use it for compound interest. We'll get more into E a little bit later, but we have this kind of lazy way of abbreviating it because it does come up quite a bit in banking. Then our other one is if I just have a log written without a subscript, written without a base, that is log base 10. And if you're like, why are they lazy? Why aren't they writing the 10? I don't know. Why are we lazy and we don't write the index of 2 with square roots? It's the same thing where this type of log base 10, comes up quite a bit in like chemistry and other fields. So if there's no base written, it is base 10. If it's natural log, why it's ln and not nl, couldn't tell you, that is log base e. So these shorthands you will have to have memorized. If you're looking at that going, what, today? No, not today. We're going to do lots of practice with these so that you get more comfortable when you see them out in the wild. So, folks, in these first examples, we're just going to be rewriting between the two forms. So, look at problem A. Is that in exponential form or logarithmic form? Logarithmic form. How do we know? It says log, so it's got the word log there. And anytime you see the word log, you think of the elephant with his big animal ears. And I like to write those letters there so that when I pull out the parts and put it back into exponential form, I know what is what. The 2 is my base. The A is my answer. Who's the exponent go with, the base or the answer? The base and the exponent are always tied to each other. And folks, when you go to exponential form, it should make mathematical sense. Is 2 times 2 times 2 times 2 times 2 32? Sure is. So whereas 2 equals 32 to the 5th, that would not be a true statement. So it should be true when you rewrite it in the other form. So let's go ahead and take a look at the next one. We see log, natural log. The first thing that I would do with this one is rewrite it as log base E. And then we got the 8. And then we got the X. So this is in log form. We think of the elephant with his big animal ears. So our base is E. Our answer is 8. And the exponent goes with the base. Hooray. It's weird. It seems kind of pointless for right now. But again, I promise that logs are important and they will lead us to be able to solve these equations algebraically. Let's go ahead and go in the other direction. So how do I know what form C is in? There's no log. So there's no log, but there is an exponent. Folks, if it just has the base, the exponent, and the answer, that's exponential form. So I'm going to label the parts. 4 is the base. What's -2? The exponent. And 1/16 is the answer. So to write it in log form, log, start with that. Then big, base 4. Animal, 1/16. Ears, -2. Folks, from an organizational standpoint, everything is at ground level except for the 4 is a subscript. So the log, the 1/16, the -2, those are all in line with each other. It's only the base that gets dropped a little bit lower. Drop the base. Let's practice reading this one. Log base 4 of 1/16 equals -2. Log base 4 of 1/16 equals -2. Let's go ahead and take a look at D. E is my base. 4 is my exponent. Bless you. And Y is my answer. So we want to write it in log form. So we think of that elephant holding the log in his big base E. Animal. Y. Ears. 4. What do you think our next step should be to make this as pretty as possible? We're going to replace log base E with natural log, ln. So ln y equals 4. And that is our expression in logarithmic form. Is this harder than the last unit? Is it harder than the fractions? It's weird, and that's why it's hard for me when people ask me if term 2 is harder than term 1, because everything's a little bit different. Is this as hard as linear programming? Those big story problems, remember those? Ugh. So it's definitely different, and it's definitely going to take some practice. But a lot of what we're just going to be doing is rearranging, and a lot of just adding and subtracting kind of operations like we did with radicals. So let's go ahead and just take a look at example 2. It says evaluate. So if I said, hey guys, what's log base 5 of 5? You'd be like, I don't know. I don't even know what a log is. What's nice is that to evaluate one log, we simply put it in exponential form. If you have a highlighter, highlight that. If you don't, draw fireworks around it. Draw a snowman by it. I'm going to draw a snowman. This is going to be a common theme throughout this unit. Whenever we have a single log, we say gross, a log, put it in exponential form. Kind of like gross, a fraction. Let's destroy the denominator. We see a log and we go, you know what? Let's just put it in the form we're more familiar with, which is exponential form. So log big big. Animal. But what are we missing?
Ear.
The ears. So we're just going to throw an equals x on the end. And the ears, or the exponent, is what we are looking for. Now, if you're excited and you're looking at your calculator going, ho, Mrs. Cairo, I see that log button. I see that natural log button. The problem is this is only for base 10. Is that base 10? No. And natural log is only for base E. We're going to be using those buttons quite a bit, just not right now when we are dealing with these regular logs. So let's write this in exponential form. Our base is 5. Our answer is 5. And our exponent is x. What does x have to be equal to? 1. Ta-da! That's what log base 5 of 5 is equal to. Congratulations, you just evaluated your first log problem. So we see a log and we go, no, let's put it in exponential form to solve it. And then we use our knowledge of exponents to figure out what it's equal to. So on all of these evaluating ones, go ahead and just put equals x on all of them. So we see the word log and we think of the elephant with his big animal ears. 3 to the x equals 81. What does x equal? 4. And if you wanted to use your power sheet, you could say that 81 is 3 to the 4th. So if 3 to the x equals 3 to the 4th, boom, x is 4. Folks, awesome work. We will resume with this tomorrow.